Now, in this experiment, we're going to look at what happens when we mix oil with water. Now, the materials I'll need to do this experiment are a clear bottle with some water inside, some food colouring, some oil and some detergent. Now, we just add a couple of drops of food colouring to the water, just need a little. Okay, and then add some oil, decent squirt of oil. And we'll put the lid on top and give it a really good shake. Shaking as hard as you can, of course making sure that the lid's on securely. Now it looks like the two liquids have mixed together, but if we just wait a moment, we'll be able to see that this actually isn't the case. The water will sink to the bottom and the oil will rise to the top. And we can see that happening quite clearly here now, the layer of oil at the top. It just would not mix with the water. And we can see here that the oil has not mixed with the water, and that's because water molecules are strongly attracted to each other, and this is the same for oil. And because they're more attracted to their own molecules, they just don't mix together. They separate, and the oil floats above the water because it has a lower density. Now, detergent is actually attracted to both oil and water and helps them to join together into something called an emulsion. So if we add some detergent here, and give it a good shake, mixing the two together, they will mix together much more easily and much more readily, which is why it makes it so easy to wash those greasy dishes. Now, this experiment is about dissolving sugar at different temperatures. The materials I need here are a glass with some cold water, a glass with some hot water, some sugar and a couple of spoons. Just be careful with the hot water, and some parental supervision may be required here. Now I'm just going to add a spoonful of sugar to each glass. Now just be careful to add the same amount of sugar to each glass to keep this a fair experiment and to keep the variables the same. Now I'll give each glass a stir. The hot water has dissolved it already, whereas the cold water, it's still dissolving. I'm going to add some more sugar now. Another spoonful to the hot and to the cold. Okay, I continue stirring. The cold water is gradually dissolving, but still has some on the bottom of the glass. I'll add another spoonful to each. If I leave the glasses to settle, there's quite a bit of sugar left in the bottom of the cold water glass, whereas the hot water has dissolved all the sugar. Now, when these liquids can no longer dissolve sugar, they become a saturated solution. This means that sugar starts forming on the bottom of the cup, and we can see the sugar here in the cold water. The reason the hot water dissolves the sugar more quickly is because it has faster moving molecules, which are spread further apart than the molecules in the cold water. Now we can see here that there is still sugar that's undissolved in the bottom of the glass with the cold water, whereas the hot water has all the sugar dissolved. Now here we have a saturated solution, which means that sugar starts forming on the bottom of the glass and it can't absorb any more. Now the reason the hot water dissolves more is because it has faster moving molecules. which are spread further apart than the molecules in the cold water and allows the sugar to dissolve. This experiment is called Water Molecules on the Move, and it's great for testing whether hot water molecules move faster than cold ones. To do this experiment, we just need a glass with some cold water, a glass with some hot water, and some food colouring, and then also an eyedropper. Now, we need to have the same amount of water in each glass to keep the experiment fair, and then add just 1 drop of food colouring to each glass as quickly as possible, and watch what happens. Now, if you watch closely, you'll notice that the food colouring spreads faster. Now, if you watch closely, you'll notice that the food colouring spreads faster throughout the hot water than the cold. The molecules in the hot water move at a faster rate, spreading the food colouring faster than the cold water molecules, which move slower. Now, if you watched closely, you would see that the food colouring is spread faster throughout the hot water than through the cold. The molecules in the hot water move at a faster rate, spreading the food colouring faster than the cold water molecules, which move slower. This experiment is called Warm Air Needs More Room, and we'll see that as its temperature rises, air starts to act a little differently. Now, to do this experiment, I've just stretched a balloon over the mouth of a bottle, and I'm going to place it into a bowl of hot water. You need to watch and see what happens. It needs to be held there for a few minutes. Now, as the air inside the balloon heats up, it starts to expand. The molecules begin to move faster and further apart from each other. This is what makes the balloon stretch. There is still the same amount of air inside the balloon and bottle, it's just expanded as it heats up. After letting it stand for a few minutes, this is the result we'll have, with the balloon being expanded by the hot air inside it.